In this video, we're going to start taking a look at some different type of isomers and specifically focusing on structural isomers in organic chemistry. So let's sort of first take a big picture view and look at different types of isomers. There's many different types. And in this video, we're going to just focus on structural isomers. So we're going to define what that is in a moment. But know that there are structural isomers as well as stereoisomers. And stereoisomers are divided into conformational and configurational. We'll get into that in another video, so make sure you watch that one. But like I said, for now, we're just going to focus on structural isomers in this particular video. So what are structural isomers? Well, they are basically molecules that have the same molecular formula, but different structural formulas. So how the atoms are being joined together in different ways. For example, C4H10 has two possible isomers. We have, for example, all 4 carbons joined in a straight line, or we have 3 carbons along with a methyl group attached. So if you were to count up the number of carbons and hydrogens, they're both equal to C4H10, but they do have different arrangement of atoms joined together. Similarly, we can look at C5H12, and there are 3 different isomers. We can have all 5 carbons joined in one row. We could have 4 carbons with a branch here, or we could have 3 carbons with 2 branches. So all 3 of these all have the formula C5H12, but you can see that they have very, very different connections. Now, it's really important to note that when there are single bonds present, there's free rotation around the single bonds. So you wouldn't draw something like this image here where you have, let's highlight in green, where you have 1, 2, 3, 4, 5, where you've kind of drawn this one off on an angle versus 1, 2, 3, 4, 5. So these are essentially the same because single bonds can rotate around itself. Just drawing it bent and up like that doesn't mean that you have anything different. And in fact, if you were to name both of these are pentane. So they are not structural isomers. The other sort of key point is that isomers can have different functional groups. So here are a couple of isomers here. One's an alcohol and one's an ether. But if we were to count up the carbons, they both have 2 carbons and 6 hydrogens and 1 oxygen. Okay, but they have different connections, different functional groups, so they are isomers of each other. Now, the last point we do want to point out is that physical properties of isomers will differ. And sort of generally, you can say that a branch chain isomer is going to have a lower boiling point or melting point than its straight chained isomer counterpart. And for example, you could take a straight chain versus a branched isomer of an alkane. And the reason why the branch chain one is going to have a lower boiling point is because it has less surface area. And when we have less surface area, we have less London dispersion forces. And so there's less intermolecular forces to overcome in order for us to break those forces and boil our substance versus a straight chain isomer, which is going to have a higher surface area and it will have higher London dispersion forces. Okay, so you can go back to looking at intermolecular forces and how they affect various different isomers just by taking a look at their structures and what we know about those forces. That's it then for this video. We'll see you in the next one.